Question number 8, unit conversion. So in this case, part A, 0.06 kilometers. We have to convert kilometers into meters, so we multiply by 1000. In 1 kilometer there are 1000 meters, so whenever we have to convert kilometers into meters, we have to multiply by 1000. 6 over 100, 0.06 means 6 over 100 multiplied by 1000, so 2 zeros cancelled. So we have 60 meters. Other method could be, when multiplying by 10, 100 or 1000, we simply have to move the decimal point to the number of steps equal to the number of zeros. So here we have 3 zeros in 1000, so this decimal point will be moved 3 places to the right. That will give us 060, which is 60 meters. Which convert 7 meters square to centimeter square. When we convert meter into centimeter, we multiply by 100 because there are 100 centimeters in 1 meter. In this case, we are actually converting meter square into centimeter square. So we will not multiply by 100, actually we will multiply by 100 square. Meter times meter is equal to centimeter times centimeters. So 100 for this part and 100 for the other part. Simple rule is, if there is a square, we use the basic one, but we take square of that. If we have simply m, simple m, when converted to centimeter, we multiply by 100. If meter square is to be converted into centimeter square, we multiply by square of 100. In some case, if we need to convert meter cube to the centimeter cube, we will multiply by hundreds cube. So in this case, 7 multiplied by 100 square means 1, 2, 3, 4 zeros. So that will give us 70,000 centimeters square. Question number 9. Write 216 as a product of its prime factors. So 216 prime factors, if I start with 2, 2 ones are 2, 0, 16, 2 8s are 16. Because if I am dividing by 2, 2 ones are 2, so 1 is left. Since 1 is smaller than 2, we will combine the next digit, but in the answer there should be written 0. So again 2, 54, again 2, 27. I think that gives us the idea what to do then. 216 will be 2 cube and 27 is 3 cube. So it would be 2 cube multiplied by 3 cube. Two positive integers each greater than 25. Their lowest common multiple LCM is 216. Their highest common factor HCF is 18. Find the two integers. So let the integers be m and n. And their LCM is 216 means 2 cube times 3, and their HCF is 18, 2 times 9, 2 times 9, 3 square. So when the numbers are written in this format, what format? Means they are expressed as a product of their prime factors. In that case, let's discuss the concept of LCM and HCF. In case of LCM, we take highest power from common. Uncommon, they are taken as they are. And in case of HCF, we take only common, but we take smallest power of common. With the numbers only from the common they are taken, and from them we take the smallest one. So m and n, from looking at LCM and HCF, what we can see here is only 2's and 3's multiples should be there in m and n, because we cannot see any other prime number. So only 2 and 3 prime numbers could be used. In one of them would be 2, and in other there would be 2 cube. Same way, in one there would be 3 cube, and in other there would be 3 square. That would make 3 cube is 27 times 2 is 54, and this is 2 cube and 3 square, so 8 times 9 is 72. So both of them are greater than 25. There could be some other option here. M could have 2 cube and 3 cube, then n would have 2 and 3 square. This is not possible. Why? Because 3 square, this is 18 and this is 216. So this is not possible. Why? Because one of the two number is less than 25. So this option or this choice will not be taken. So we will rearrange these powers and these numbers in such that we must have m and n, means these two integers, they must be greater than 25. The diagram shows triangle A and B. Describe fully the single transformation that maps A onto B. So A onto B, the statement of the question is, describe fully the single transformation that maps A onto triangle B. Triangle A onto triangle B. Describe fully the single transformation that maps triangle A onto triangle B. It means triangle A is object and triangle B is image. It means A is mapped onto B. If we build a relation, if I take the top corner of this triangle, this has moved 1, 2, 3, 4 units to right and 2 units down. This transformation is translation, defined by translation matrix, or simply you can write translation with translation matrix 4 minus 2. The other way is, if I take any object, this corner which is making right angle means this is object and the coordinates are 3 minus 4 and its image is 7 minus 6. So if you remember, we have talked about object plus translation matrix is equal to image. So translation matrix will be image minus object. So here image is 7 minus 6 minus object is 3 minus 4. Here O I am using for object, not for origin. I for image. So 7 minus 3 is 4 and minus 6 minus 4 is minus 6 plus 4, which is minus 2. 4 minus 2. The second part, the B part, is the triangle A is mapped onto the triangle C by a rotation of 90 anti-clockwise, center 0, 0. Draw the C. So in the second part, it is rotation 90 anti-clockwise, center is 0, 0, object is A. This is a special case. If you remember, we talked about the special case. In this special case, center is origin and this is 90 anti-clockwise. If you remember, the object xy, when rotated through 90 anti-clockwise about origin, that becomes minus yx. So if the object is A, the three coordinates, one is 2 minus 4, 3 minus 2 and 3 minus 4. So these are the coordinates of objects. So under this transformation, xy becomes minus yx. It means y takes the place of x after changing its sign. So it will become 4 and x becomes y, 4, 2. 3 minus 2 will become 2, 3 and 3 minus 4 will become 4. The image will be 4, 2, 2, 3 and 4, 3. This will be C. The other method could be, if we physically rotate, we join each point with the origin, and then at origin make angle of 90, and then rotate this one 90 anti-clockwise. We know the diagram will be this shape, so we can trace this one. This is the special case, so you can directly do this one. If A is rotated 90 anti-clockwise, the horizontal lines will become vertical and vertical will become horizontal. This is isometric transformation, means object image, they are congruent. The turning of 90 anti-clockwise will give us a triangle like this. C part is triangle A is mapped onto triangle D by an enlargement, scale factor 3 and center 5 minus 5. Scale factor 3, 5 minus 5. Quickly I revise concept of enlargement. Object, image and center, they are collinear. They always lie on the same straight line. They are collinear if scale factor is positive. Object and image, they are on the same side of center. And third point is distance of image. Whenever we talk about distance, distance is always measured from the center. So distance of image is k times, means scale factor times the distance of object from center. Center 5 minus 5, scale factor 3, center and object is A. 5 minus 5. Let's locate the center. This is center of enlargement. Scale factor is 3. The image will be similar to A. Scale factor is 3. Each side will be 3 times the corresponding side of A. Means that will be right angle triangle of the same shape. Each side will be 3 times the corresponding side of A. The vertical right side is 2 units. Image this side will be 6 units. If I draw a line from object to center, the distance from this center is in terms of column vector, that is 1, 2, minus 2, 1, 2, 3. So this distance written as a column vector is minus 2, 3. So this is distance of object from the center. So distance of image is k times, k here is 3 times the distance of object from center. So that will become minus 6, 9. So it would be minus 6 means 1, 2, 3, 4, 5, 6 and 9. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here you can see object, image and center, they are collinear. By using common sense we can draw the whole diagram, because the diagram will be similar to A and each side will be 3 times. So the triangle will be this one.